we were discussing the product of sum. So in definition, when two or more sum terms are multiplied, the result expression in a product result expression is a product of sum. As an example, suppose the first term in the first row is a bar plus b, that is a sum term, and again a plus b bar plus c again is sum term, and both sum terms are multiplied. When such type of expressions are there, we say that this is a product of some form. So all terms which are here may be a single with a single lead variable or a multiple variable. Suppose this is an example that a bar is a single variable multiplied by a bar plus b bar plus c multiplied by b plus c plus d bar. So these all are called as product of sum. Now we took into mind that in a POS form, a single overbar cannot extend over more than one variable. However, more than one variable in a term can have an overbar. So when we can write like a example, for an example, that it is a plus b, a bar plus b bar plus c bar, it is okay, but when we cannot write in like a plus b plus c whole bar. So because when we solve it using using De Morgan's theorem, then it comes a bar and b bar and c bar. So that will be a product term, not the sum term. Now for the implementation of the POS, suppose we, for an example, we have x equals to a plus b and b plus c plus d and a plus c. So here we have three terms which are ended, and all three terms in the first term it is a plus b, that is done with the help of OR gate, then b plus c plus d again an OR gate, then a plus c again an OR gate. So these can be implemented with the OR gates like this. The first gate provides an output a plus b. Next gate gives a b plus c plus d. Next gate gives a plus c. So and all terms are multiplied, and the multiplication is done with the help of AND gate, and the output of all gate is the input to the AND gate, and we get x equals to a plus b and b plus c plus d and a plus c. So in this way we can implement a POS with the help of OR gate as input and AND gate as at the output. Now, as we have studied in case of the SOP, that is standard or canonical SOP, in the same manner we have standard or canonical form of product of sums. Now, how to represent it? With the same as we have done in case of SOP, a standard POS expression is one in which all the variables in the domain appears in each sum term in the expression. Means every term should have all the input variables in each term. When we represent in such a way that it is said to be a standard or canonical POS form. For an example, suppose we have a bar plus b bar plus c bar plus d bar and a plus b bar plus c plus d and a plus b plus c bar plus d. Now we have three terms, and all three terms have available all four input variables. So here the input variables are a, b, c, d, and the input variables may be in terms of true form or in terms of the complemented form. So when such type of expression is there that each term has all available variables in each term, then it is said to be a standard or canonical form of POS. Standard POS expressions are important for constructing truth table and the Karnaugh map or K-map simplification method, which we are going to discuss in the next topic will be our Karnaugh map. Converting a sum term to the standard POS when it is required. Now for the same, we have for the first step, as we have done in case of SOP, add to each non-standard product term, and the non-standard product term is the term in which any input variable is missing. For this, add to each non-standard product term a term made up of product of missing variable and its complement. This results in two sum terms. Now we'll discuss it with an example. As you know, you can add 0 to anything without changing its value. That is the property we have studied when we are discussing the postulates or laws of the Boolean algebra. The x plus 0 is equals to x. Now 0 can be y into y bar. So this is the concept here. Now step 2, we have to apply rule number 12, that is a plus bc equals to a plus b and a plus c. So this is a postulate we have studied already. So with the first step, we will add a term. This term bc will be, suppose y is missing, so this bc will be y and y bar, and when we expand it, it will be a plus y and a plus y bar. So this is the process which we have to apply when we are converting a non-standard POS into canonical form of POS. Now for step 3, repeat step 1 until all resulting sum terms contain all variable in the domain in either complemented or uncomplemented form. And we have to repeat step 1 every time if there are more number of missing input variables. Now take an example for the same. Now we have to convert the following Boolean expression into standard POS form. So first of all, we have to find out that how many terms are there. So here 1, 2, 3, 3 terms are there. The first term and the number of input variables A, B, C, D. We have 4 input variables. That means, and the last term has complete input variables. First term has A, B, and C. That means D is missing. In the second term, we have B, C, and D. That means A is missing. So what we have to do, we have to convert first and second term into the standard POS. Then we have to combine the expression, and that can be done with the help. Suppose for the first term, A, B bar, C. So what I can write it like A, B bar plus C plus 0, and 0 is the missing term, that is D and D bar. If I take this A, B bar plus C as A, so A plus B C equals to A plus B and A plus C. So it is A, B bar plus C plus D first term. Then I have A, B bar plus C plus D bar. That is the next term. So in this manner, we can convert any non-standard form into the standard form. Now for this first expression in the standard form will be A plus B bar plus C plus D and A plus B bar plus C plus D bar. Now same will be done for the second term. Second term is missing with the input variable A. So we have to write it like B bar plus C plus D bar plus 0, and 0 is nothing, A plus A bar. Whichever term is missing, we have to put that term. So when we expand it, the first is A plus B bar plus C plus D bar. This is constant and added to the first term. And again A bar plus B bar plus C plus D bar. This is the second term. And when we combine it into like this, so this term, first term is red in the red lines, second term is in the green line, and the last term is in the standard form, then the expression is converted into the standard form. Now the binary representation of a standard sum term. A standard sum term is equals to 0. So as we have studied in the max term and the min terms, that is the product terms are represented by 1, and max term are the sum terms which are represented by zeros. So in the same manner here, if the value is it is just the complement of the product term. But if A is in the true value, we'll have a value 0. As if B is complement, if the input is complemented, it will be have a value of 1. So if this was the case of SOP, then the value A is represented by 1, and in this case A is represented by 0. It is just complement. So we can write it is 0, 1, 0, 1. The value of A is 0, B is 1, C is 0, and D is 1. And can be shown that if we put these values, then it will be 0 or 1 bar or 0 or 1 bar equals to 0 or 0 or 0 or 0. This 1 bar is, that is complement of 1 is equals to 0, and it comes to be 0. And we can have that, and this term is 1 for all rest combination, as in case of min terms, that particular min term is 1, and the rest of the combination, for the rest of the combination the value will be 0. So here in this case the max term have a value of 0, and for the rest of combination it will have a value of 1. Okay, I think let's stop today's lecture here. We'll start